How's everybody doing? Oh, come on, man. Work with me. How you doing? Look, I know it's after lunch. And I know that we're probably one of the few things that stands between you and going home. All right? So our goal is to give you a good session whereby we cover the topic. We share with you what we think about it, but we also reserve some time for some good Q&A. Is that fair enough? All right. So we're here today to talk about the digital transformation as it pertains specifically to the digital twin. How many of you guys know what the digital twin is? All right, good deal. It looks like about 20% of you maybe know what the digital twin is, right? All right. And the interesting thing about the digital twin is that there are lots of different definitions that people use. Is it okay if I talk from here? You guys hear me okay? Yeah, good deal. I don't want to be leaning all down here talking off that thing there, right? All right, good deal. So let's think about the digital twin this way, all right? On the one hand, it is a visualization. On the other hand, it is the physical asset. So the digital twin really is about bridging the gap between the physical asset and the digital creation in a visual way. But that's kind of interesting, but that's not really where the power of this thing actually works, right? The digital twin actually goes all the way back to NASA. Anybody remember Apollo 13 and how those folks got stranded up there, right? And when they brought them down, they actually had a digital twin that actually replicated what they were dealing with, and they were able to tell them, here's how you can take this duct tape and bubble gum, fix things, and bring yourself home. Well, hopefully none of us will ever have to go to such extremes, but when you think about this industry, and you think about the digital transformation that's actually been occurring, we now have the convergence of multiple things that enable the two digital twins in terms of the concept. So we always know that with IoT, we have the convergence of information technology, operating technology, and advanced communication technology, right? And that gave us IoT. Now we add to that AI, machine learning, and virtualization. And now we can actually create the digital twin that can actually allow us to optimize how we're actually managing the business of delivering electricity on the grid. Utilities will always focus on delivering safe and reliable energy. This gives them another tool to actually have. All right, so my name is Ernie Lewis. I work for a company called Bridgewater Consulting. I'm the Senior Vice President in charge of business strategy. But the thing that might be a bit more interesting about me is that I have 27 years direct experience on the other side working for an actual utility. Matter of fact, our company comprises almost solely of folks like that. I have a total of 37 years in the industry, so I've seen it migrate and evolve, and lots of evolution has actually occurred. My panel, these folks have some additional qualifications, so let me just turn it over and have them introduce themselves, and then we're going to dive right on in. Is that fair? Yes, sir. All right, good deal.
Thanks, Ernie. Can you all hear me okay? Yeah, thanks. I'm not from around here. You might have guessed that by the accent. My name's Ty. I'm from Australia. I've got 33 years experience in the electricity supply industry. Yes, I know, hard to believe. But thank you. I'll pay you later. I work for a company called Endeavour Energy. I'm an executive there in charge of asset management. Endeavour Energy is a poles and wires and cables business. We don't have any retail functions. In Australia, the way the market's structured, we're legally prohibited from being both. We can only be either or. We serve the Sydney surrounding areas, not the bit with the Opera House in it, but all of the other parts of Sydney are supplied with energy by Endeavour Energy. And importantly, we serve some of the greatest growth areas in Australia. In fact, the area that we supply is, in its own right, the third largest economy in our country due to the rapid expansion of the City of Sydney. Thank you.
Great.
Thank you, Ty. Tough act to follow. Sam Phillipson. I work for Siemens Industry in the Energy Management Division. My background is in software engineering and computer science. And I've worked for about 25 years with various utilities around the world, delivering software for power system modeling and simulation analysis.
Very good, thank you.
Alfredo Contreras, excuse me, I think allergies are getting to me. Alfredo Contreras, I'm with Bentley Systems. I'm a product manager for products that we're currently developing jointly with Siemens. So I actually work with Sam a little bit. My background is also computer science and working within utilities. LADWP was, I worked there for about 6 years. And Right now, like I said, I'm managing some new product lines that we've recently released.
Okay. Great. All right, good deal. So let's dive on in, shall we? All right, so we've already talked about the digital twin, what it is, things of that nature. So, but what I also recognize, what I asked you, how many of you guys knew about it, if you did, there are different definitions of what it is. So let's just start with our panel, shall we? Let's give them a softball, I call it. And let's just ask, what is your definition of a digital twin? We'll start with Ty, we'll work our way around to Sam and Alfredo, then we'll come back to me, and then we'll go to the next one. Go ahead, Ty, what's your definition of a digital twin?
I think if you ask a room full of people in our industry, 10 people, what the definition is, you'll do well if you get 10 different answers back. Probably I've got about 2 or 3 myself in terms of what is a digital twin. The reality is the technology that's available to us to create a digital twin, to inform it and to keep feeding it, is constantly changing, constantly evolving. So you could say a digital twin it's an environment in which you can bring together data from multiple different sources, manipulate, view it, and use it in a way that's most helpful and in a way that's very user-friendly. But if I was to put it, because our chairman said, keep it short, I think it's a journey. The reality is the digital twin is a journey. Wherever we're at now, whatever digital strategy you might set for yourself as a company, by the time you've executed it, the world will be different than it is now, and you'll need to keep evolving, keep ahead of the new technology, and keep bringing that into your digital strategy. So my short answer is, it's a journey.
Very good, thanks. Sam, how about sharing your view on that?
Yeah, everything that he just said. Plus, I think there's an aspect as well related to the journey, which is that, to me, to be as generic as possible about it, a digital twin is a computer model of something in the physical world. That's really, there's nothing terribly new about that concept, but what's new, I think, is the technology that we have that can make that, realize that concept better. And to me, one of the possibly overlooked aspects of an electrical digital twin is that it's not enough to model the grid as it is today. It's certainly necessary and it's certainly useful, but it's also equally, or maybe not equally, but importantly useful to model the grid as it will be and as it might be in the next 1 year, 10 years, 20 years. And I think that's where a lot of the challenges are in maintaining a digital twin. If you just had to do it one time and you got it all right and it was good from that point on, it wouldn't be so much of a challenge. So I think really the journey aspect is also the journey of the digital twin itself as it goes from its current state to reflecting the future reality.
Okay, great. And Alfredo?
Well, to add to everything that they've said, and I agree with what they've said, I think it's also about breaking down the barriers between technologies, breaking down barriers between data silos, and even breaking down the barriers to collaboration between people and departments, planning, design, operations. That's what I would add to
Okay,
that.
great. So we all know that in the utility industry, what really matters is how you can affect change in getting the job done, right? You can always deliver that safe, reliable energy. So we're going to shift our focus down and talk a little bit about use cases, right? I told you the story about the Apollo, right? That's kind of interesting. Probably in around 2002, things got pretty serious with it, right? But now as we're looking at some of the use cases, we're literally seeing people that are actually putting this in operation. So imagine with me for just a moment, right, that you have an operator that's trying to run an energy management system, and they're trying to deal with some of the devices that are distributed out there, and they're trying to push control and push decision-making further out to the edge. But they really don't have all the information local with the folks that are out there. But if I had a digital twin, and I could actually have that digital twin made available to the folks that are actually out in the field on their tablets where they can actually see it, where they can actually take it apart, where they can understand where the specific problems are, and then communicate back to the office. Now the digital twin becomes a tool, right? That's one use case. This stretches across multiple use cases in our industry as well as other industries. So let's ask our panel what might be some use cases that they have thought about or come across. So let's start with Alfredo this time.
Okay, thank you. Well, one of the use cases that we, I should say, Bentley and Siemens identified some years ago is that we were seeing a lot of DER being introduced into the grid, and we were seeing customers saying that they were having big problems in terms of managing those requests for interconnections. So one use case I can tell you what makes a big impact is simply being able to manage just the volume of requests that are being introduced by the customers and even by third parties that wish to add generation into your system. It's understanding the return on investment for yourself, of course. How do you manage that? It's a big problem, and a digital twin, I believe, can assist with that. Let
me just ask you a follow-up. So what part of the twin in the DER scenario are you really focusing on there? Which piece is actually being replicated from a digital twin standpoint?
Okay, so in our case, we actually started with distribution. We integrated asset information management with GIS and with calculation engines, Siemens SynCal, into one unified system that is able to manage asset information. Both it understands both what is there today. You can model what was there previously, and even as you're adding, let's say that you're adding a new DER to your system. Well, if you're calculating, for example, many utilities have hosting capacity maps, for example. The fact is that as soon as you add another DER to that system, that hosting capacity map has changed.
Right.
And it's about having a continuous model. Digital twin, that's what it gives you. It gives you continuous updates to your capacity.
Right, and you can see those changes near
real time.
Correct. And you can visualize them as appropriate, which again, when you think about kind of transforming how we worked in the past in the industry when those kind of scenarios occurred, right? It's almost like moving from prehistoric to current times, right?
Right.
So, Sam, what can you add to your use case experience here?
Okay, I can talk a little bit about the transmission side. So let's think about a grid expansion project that may be planned for 10 or 15 years in the future. That's probably going to be modeled in some kind of planning tool and analyzed well in advance. But that project potentially has a life cycle. So eventually that project might be approved and it may actually become close to being a reality for operations. And it might involve new construction and things like this. So the use case would be to preserve the information that was originally entered and modeled by the planning engineers, and to reuse that information and enrich it further as we get closer to design and actual deployment in the physical grid. So ultimately, you start out with sort of a skeleton, and then as you get closer to the point of commissioning, it gets more developed with the details it needs to support, EMS and other systems. So you're never duplicating the data entry that was done originally. You're consolidating everything in a central system, and you're reusing all this information from multiple groups in the organization and centralizing it to avoid the data redundancies and the duplication of errors and things like this. So that to me is another interesting use case.
Okay, great. And then Ty, I'll let you round it out.
Thank you. Yes, and I get to be the yes and person.
You're the yes and?
This round, don't I? Endeavour Energy, we've scanned our entire network, all of our above ground assets, over 24,500 square kilometres. What's that? 13,000 square miles or more. And all of our above ground assets into a digital 3D network model. We found the use cases for that. We originally thought of about 9 use cases, so I'll mention some specifics in a moment. By the time we'd commissioned it, we had 15 use cases, and we're currently working on another 5. The business case for it was originally planned to have a 3-year payback, and it turned out paid back in 12 months, and we've been building on it since then. The use cases specifically, we found a tremendous benefit in our asset management and our asset management planning through conflating the data from various different sources, that breaking down the silos that my colleagues here were talking about, and specifically bringing together GIS data, our enterprise asset management data, and being able to visualise that in a very user-friendly way has substantially improved our asset management decision making. That's then flowed on in our design office. We're now saving money as a business in a hard sense by the fact that we no longer do field-based surveys or field visits prior to undertaking designs. It's all been captured, it's all there in the point cloud, and it's all there available on the desktop for our designers across the board, across our entire franchise coverage area. We've also found tremendous benefits in the work scheduling area. Where we've got our work schedulers, some bright spark within the business when he found out this was available, now brings up the 3D model in the top right-hand screen when he's programming and scheduling work, is able to visualise it and make sure that based on what's real and on the ground there and the latent conditions, we can roll the right trucks, the right people, the right equipment, the right materials once and once only. And then last but by no means least, we've found tremendous use case benefits in managing vegetation and vegetation risk from a public safety perspective, but also our franchise area, we operate at a latitude that's about the same as California, but don't hold that against us.
Hey,
only on the other side of the equator, of course. And so what you here would call wildfires, what we in Australia call bushfires, is our greatest corporate risk exposure. And the risk of taking too long, I'll just stop there and say we've found the benefits of a digital map of your network and its interaction with the built and growing environment is of the greatest benefit in managing that significant risk.
All right, very good. So a couple of things that I want to just kind of call out as we transition to our next question, right? There are a number of elements you've heard these gentlemen talk about that you kind of have to get right in order for this to move forward, right? Data being one of them, right? And of course, data by itself is just useless, let's be candid. If I can't turn data into information, I cannot create informed decision making, nor can I feed the digital twin. In order for this to actually be as powerful as they're talking about, you've got to get that piece right. Secondly, you've got to have accuracy, right, in terms of how you are creating the asset, right? The asset has got to mimic reality, whatever that asset may be. Now, by the way, the asset can be a physical thing, it can be a process, or it can also be a service. So that also makes the digital twin a bit more powerful and more varied than just being narrow. But before I go on, I decided to do something different. I'm going to go off script. I didn't even tell these gentlemen this, right? I'm going to ask you guys a question. So what is a business case that you're interested in for your area? What are you thinking of doing with the digital twin? Yes, sir.
Since we're ready for like cybersecurity, if you have something submitted for NERC compliance or whatever you have, somebody's trying to strip some copper off the substation to some actually nefarious guys doing different things. How do you layer that into your digital twin planning? Because you're going to have all of the data you have to be corrupted or asking your ghosting or whatever. What is your guys' outlook?
All right, great. So the question is around, and I'll probably get it messed up, but do me a favor, correct me if I'm wrong, but for those that didn't quite hear, it's kind of around cybersecurity and also around physical security. right? How do you deal with people that are trying to come rip off your copper, trying to strip it out, trying to, basically violate your system, and how do you layer that in from a digital twin standpoint? Is that fair? Good deal. Who would like to take a stab at that? No, he shook it off. All right, that's fair. Ty, it's either you or me.
I'll give it a go.
All right, let's go.
As they say. From my company's perspective, it's fair to say we're still on the journey, and there's steps on the journey of creating what I would really regard as a digital twin. At the moment, we have a digital model, and so for real-time interaction with the network, I think we're still reliant on some of the more traditional technology that you'd have for monitoring. One of the things, though, that I will say from a cybersecurity perspective is a religious zeal around physical separation between IT and OT systems is something that we've learned as a business from others. Is something that we adhere to, and I've got to be very careful now, given ownership changes recently within our industry. There's national security clearance has to be held by certain executives, myself included within the company, which limits what we can say publicly even about our cybersecurity. But suffice to say that intense focus on physical separation of traditional IT and OT is an absolute foundation, and something that federally people are very, very concerned about. In terms of day-to-day intrusion and interaction, all the usual things, and I think this is part of the evolution of creating a digital twin. Video surveillance in particular is one thing that is becoming more and more affordable, and what we're seeing is now, as 5G starts to emerge as a technology, just what that does for all of us in the industry in terms of opening up bandwidth to be able to do so much in the Internet of Things environment and monitoring. We're sitting there salivating as engineers at what that's going to open up for us, but we're not there yet.
All right, and I would just like to add something on that piece of it. One of the things that I focus on for our company and business strategy is making sure people actually think through what they want to accomplish with the technology. So when you talked about that particular scenario, that's a great example. And I don't see the folks, I was at lunch with a table of folks when this kind of came up, and one of the use cases literally was, how do you integrate what's happening at the substation, both in terms of unmanned substations, as well as in terms of the substations that are kind of on the condition-based maintenance schedule, and taking the technology, all those kind of things, bringing those things in. But the key point, in my view, is that you've got to have that on the front end in terms of what you're actually trying to accomplish. Too often folks get a little happy on the technology, not you, of course, but if you don't get the front end piece of it, all you're going to do is you're going to spend money without achieving it. So I think that's it. Shall I ask them a question again? I kind of like y'all's questions better, but I got one more out there. You guys okay with that?
You go.
All right, gentlemen back there.
You were talking about the things you need to get right.
Yes.
And you stopped at data and accuracy. Are those the two things?
So those are the first two that I said, but you know what? That's a perfect segue, because the next question I'm going to ask these guys, what are the things that you must get right in order to make this thing successful? So I appreciate that handoff. So gentlemen, what are the things that you must get right in order to be successful from the utilities perspective, right? Mm-hmm. Who would like to go? Go ahead, Sam.
I'll start anyway.
Yeah.
So yes, data quality and accuracy is obviously key. That's not always the starting position, but it's achievable with a certain amount of work, and it's more or less of a challenge depending on what domain you're in. And typically in transmission we have pretty solid models, because they're used for planning, they're used for operations, EMS, state estimation. Really good way to see if your model is good is to run a state estimator on it and see what numbers it gives you. How close is that to the real world? But I think really what I wanted to say was the technology is is really everything. From my perspective, and you can't realize your vision without solid technology. Now, and I think in my experience, sometimes it's difficult to differentiate between something that is flashy, that took 2 weeks to hack up as a prototype, and something that is not so flashy, but has been in production for 20 years and has been pounded on and pounded on and pounded on every day, and bugs have been fixed, and hundreds of person hours have gone into refining this core technology. So I guess that would be my recommendation, would be look for some proven core technology that does the real grunt work, so to speak. If you're, I'm thinking particularly about like simulation engines, that's one example, but modeling technology is also important as well. And so having this solid core technology base, you can do things with modern UIs and things to add those flashy features that you want, and that will impress people who are looking at it. But I think having a solid, reliable technology backbone is essential.
Great. Phil, look, you want to jump in?
Oh,
you want to share something there?
Well, actually, I just wanted to add to what he said. Being a software engineer myself, I agree with what he says, but I've also been involved in a lot of projects with a lot of customers, and I think one of the big mistakes that happens often is that the scope of what they endeavor to accomplish is too big, and it's really, you should focus, divide and conquer, essentially.
Yeah.
That's how you do it.
Prioritize.
You limit, you prioritize it, and determine which of those are going to be high impact,
Right.
and hopefully low-hanging fruit, and then, that's what you have to get right.
Yeah, very much so. Ty, you want to add anything?
The two gentlemen have said it all, Alfredo in particular. Build a foundation, do this in stages. This segues into, how do you make a business case even for all of this, for a digital twin? Something that requires a large number of years, an infinite number of software engineers typing away furiously, and millions and millions, tens of millions of dollars, which will realise its benefits just at the end in terms of delivery, is always going to be a challenge, both in terms of physical delivery as well as in terms of getting it over the line within your business. Whether it's low-hanging fruit, whether it's quick wins, or whatever else, getting early runs on the board, as we might say in Australia, it's all the same thing. Break it up into building a foundation, and then you've proven your case and can expand from there. Don't try. That's why I was saying, I suppose, at the start here, what is a digital twin? I see it as a journey. Don't try and do it all as one big project and one big implementation. Pick something that's going to give you a benefit and build a foundation, whether it's a capture of everything you've got above ground in a digital model, whether it's a more software engineered digital performance model of how the network's going to behave under certain circumstances. Lock that in as your base, and then build incrementally from that.
Yeah. I'd ask you guys to think about this as well. The digital twin is also another convergence that's going on. It's a bit of a convergence with your data strategy, if you think about it. It's a bit of a convergence with your asset management strategy. And it's a bit of a convergence with your operational excellence strategy.
Correct.
When you think about those things coming together. So when we think about what must we get right, figuring out how to not boil the ocean, to coin the old phrase you've all heard, right? I was talking with a gentleman earlier, and we were talking about the fact that in order for the digital twin in the application of emulating your entire grid. So think about the grids that you support or work with and the size of those grids. And think about all of the assets that you would actually want to have sensors and things on to feed the information into the digital twin that emulates your grid. And think about how long it would take to actually do that. You kind of need a roadmap, right? Even if you had $1 billion to do it all at once, physically, you couldn't do it. So the other thing that you kind of have to get right is understanding what other strategies are feeding into your digital twin. Digital twin itself is not a strategy, right? It's an enabler to a set of strategies. Make sense? All right, good deal. Yes, sir.
I have a question.
And then I'll get you in the back. Yes.
So I'm going to stay away from, diverge a little bit from the conversation just because I listen with the panel. So I happen to be a twin because I was born in June, so I'm Gemini.
All right.
And I happen to have real twins, twin boys.
Okay.
So they're not digital, they're real.
That's okay.
And one of the things I find fascinating with those boys is that they're very unpredictable in terms of who's actually behaving wrong, who's actually behaving right.
Mm-hmm.
And when they come up to me and says, he did it or he did it, I'm stuck because both are telling me both did it or both did not do it. And I'm
I got you.
confused in terms of who.
Mm-hmm.
So as we go down this path of digital twin, because I live this every day, how do you trust the twin?
Yeah.
And then also, if you expand this conversation, the twin comes back to the customer, because we're creating digital twins of our customers.
Yes.
How do you, as an engineer, develop the knowledge to be able to deal with a twin, which is kind of a digitized version of reality, who may give you one behavior, but then you have an old 765 kV substation or 135 kV substation,
Yeah.
whose behavior is completely orthogonal to what the twin is doing. So you're sitting there as an operator, and now you have, from an operational standpoint, from a customer standpoint, the behavior of the twin versus the real behavior of the asset.
Yeah.
How do we reconcile that over the next 5, 10, 20 years? Because I think this is going to take off, and
Yeah.
20 years from now, I will know the answer because my boys would have taught me.
Yeah.
But if you don't have twins, you will not know the answer. So how do you fix this?
Yeah. So let me start, and then let me hand off, all right? So I'll start at this level, and I'll let these gentlemen take it a few levels deeper, right? One of the other key things about the digital twin is you're really looking to gather the data from the actual real operation. Now let me pause there because that's critical, right? You've got to be sound, back to the foundation of technology, on gathering the data from the real asset, okay? And then you've got to have models that exercise expectations of the twin. And just like when you're doing other engineering, the same way that in the room, how many engineers are in the room, by the way? Okay, this is good. All right, so just the same way you engineer other solutions, and you test those and you validate all those things before you go live, right? You don't just throw a building up and hope that it's straight and hope that it's sound. You test all those things, right? Similarly, before you cut over to using the twin, do the same thing. And that takes time in order to do that. And it takes accuracy. Remember I talked about accuracy earlier in data? So I'm with you. Now I will also say this. Every asset may not be eligible for digital twin application for reasons that you just said, right? So you also have to be thoughtful about that roadmap that we talked about, right? And then once you build the confidence of that behavior, then you can now use the twin as a tool, as it's supposed to be. And now, there's lots of different applications there. I'm going to cause myself to stop because I feel like I want to go to the next one, but I'm going to turn over to my panel and let them also answer the question.
Yeah,
How do you trust
I don't know all the answers to all the questions, but I do have one idea about this question in particular. So you have a digital model and then you have the real world. How do you keep them in sync? Well, there has to be some communication, between the real world and the digital twin, and that generally is either someone going out and scanning something, or someone going out and looking at a nameplate and then punching in numbers, or it's a measurement in the field. So most of the experience I have with this particular question has to do with measurements, like RTU measurements that come into SCADA. And so you have this situation a lot in state estimation, where the state estimator is a mathematical calculation, right, that estimates the flows and voltages across a system given limited measurements. That's what it is. Okay, for anybody who didn't know. And so your state estimator could be saying, oh, the flow is 15 megawatts here, but your measurement is saying something different. How do you know which one to trust? I mean, even the measurement could be a bad measurement. That happens too. Sometimes the quality's bad or something. Okay, so there's no one good solution, in case anyone was thinking I was leading up to something magical. There's nothing magical, but there is something that's almost magical called redundancy. So if you have redundant measurements, we can implement algorithms like switch status correction. For example, if I've got a switch and the switch measurement is saying that switch is open, but the flow measurements around it are saying I've got power flowing, one of those two things has to be wrong. And if I've got 4 flow measurements, but I've only got 1 switch measurement, I'm pretty confident the flow measurements are telling me the truth and the switch measurement is lying to me. So I think that's just one way of addressing that type of challenge, is by having a lot of measurements, so to speak, of your physical world and regularly processing that information to update your models.
Absolutely. In the interest of time, I'm going to take the gentleman in the back had a question, and then I have one more I want to give to the panel. So go ahead and speak loudly, please.
I was just going to go with the question before that. It kind of leads into this question. Really kind of, for us, we kind of broke it down into 3 things. One was a single point of truth. Gathering, understanding where you're going to gather that truth and who's going to be the owner of that truth, right? And then the adjustment and the check and balance of that truth, right? So a single point of truth. Model integrity. That's what you were referring to earlier, right?
Yep.
You've got to make sure that the models that you have the correct information. Because if not, then you can start off with an error.
Right.
So model integrity, but I think the thing that links those two together is discipline. What I heard you saying earlier, define what your goal is going to be, define what that win is going to be. Because if you don't have that discipline, you can get off in the weeds very, very quickly. Well, we got this would be cool to get that. You want to go from point A to point Z without hitting the points in between, and you can lose your way.
Yeah.
And so I would recommend those 3 things to you. That's what I heard you guys say, but those 3 things kind of be guiding lights to you, this transformation and this journey of digital twins and digitalization.
Right. Very good.
Mr. Chairman, just since I asked a crazy question, may I just interject?
Yeah, certainly you can.
So I don't disagree with either responses.
Okay.
But I just remind us of the blackout of 2003.
Yes, let's go.
We had a state estimator.
Yep.
That told us one thing.
Yeah.
But what the digital twin doesn't do is factor in human error.
Absolutely. Right.
And so you can have all the digital twin you want, all the intelligence. The blackout, state estimator said A.
That's right.
The operator said A plus B, and we ended up with a blackout. So
that's right.
Just a cautionary tale here. I love digital twins.
Yeah.
I love twins, obviously. I do.
That's right.
But,
that's right.
Just keep in mind the whole issue of human error.
Love your point. This goes back to what I said, that every application is not appropriate for a digital twin, right? And in some cases, you definitely have to have it. Boy, the hands are flying. We may not get back to our questions. I don't really care. I much prefer hearing from you all. I saw this gentleman first. I saw that gentleman second. And then we'll wrap up on time so I don't get the red light. Yes, go ahead, sir.
I'm going to count Lawrence a little bit on this one because I've had some experience with digital twins, and I find that human error is one of the biggest issues out there that digital twin actually erases.
Yeah, okay.
Things like vegetation clearances, conductor clearances. Now, when you look at PG&E, $30 billion of damage there, and you ask yourself, if I had a different world, a digital world, a virtual world, all conflated information in there that was up to date, was there a possibility those events would not have happened?
Right.
So how do you use your digital twins to de-risk these?
That's the key.
businesses?
Absolutely.
My experience is that you can get significant de-risking using a digital twin over the human judgment.
Yeah.
If I could just add to that, look, I couldn't agree more. We've been using LiDAR technology to help manage vegetation and bushfire risk, as well as high resolution digital imagery now for more than well over half a decade within our business. I can still vividly remember the first time we flew LiDAR over the network and received the volume of intrusions that revealed for us, and the defibrillators needed to be issued up and down the executive area of the company. The reality was, it only told us what had already been out there, because human beings had for years been, that's about right, that's the right clearance from the mains. That had been the method of assessing using human beings. So I've got to back up the comment that was there in terms of a digital twin. All it did was tell us with the binary language of a computer what was and what was not actually compliant to our risk standards. It was just a bit of a shock to get it all at once. Right. But it does de-risk your position. Once you understand that, you can then start taking the appropriate actions.
Right, and notice in each answer that's coming, it keeps coming back to the correct application. Right, thinking about it, it's not a panacea, but it's very powerful when deployed correctly. Yes, sir, in the very far back.
So just hearing all the conversation about digital twins, both there and elsewhere. I feel like the thing that is missing is some qualification before digital twin. You know, back in the dark ages when I was an engineering student, I learned that all models are wrong, some are useful. And what I mean by that is, you know, when you're talking about a model that represents a design model, right, and as built of something, well, you expect that to have very high fidelity. You expect it to behave in the digital world exactly as it does, to the extent that engineering mechanics are real too.
Yes.
But you're talking about risk analytics, you're simulating vegetation failure and what it does to the reliability
In that
of the
case,
system.
yes.
It is inherently a stochastic system, and therefore what you expect to get out of the twin is inherently different than what you get out of an engineering model. So I feel like the language of digital twins itself is not rich enough at this point. It's like saying I'm going to use metal to build a structure.
Yeah.
It depends on what you want to do. What kind
Yeah,
of metal.
yeah, yeah.
So I think it's the old language about, you know, those who know best have very finely nuanced words to describe things.
Yeah.
Like the Inuits have 19 words or whatever it is to describe lights. I feel like digital twins need that language enhancement.
Yeah, I think that there's that plus a little bit more. So let me just end with this. One of the things that I've been around long enough to see is multiple hype cycles. You guys know what a hype cycle is, right? And so,
Just while you're talking.
I guess you can look at that and listen to me at the same time. At any rate, when you think about the hype around these things, right, it's really essential to separate what we call the wheat from the chaff, okay? And so, to your point back there, one of the questions, and therefore the last question that I'm going to pose to the panel is, given the hype cycle that actually exists, right? Not only do we know what we have, not only do we need to think about what we have to get right, but we need to think about risk, right? So what are the risks that we need to be thinking about when we enter into a digital twin journey? And we're going to start with Ty, right? And I guess now he'll talk and we'll figure out the back of it.
No, there's
But
just something to have a look at.
Yeah.
The biggest risk that I'd see with it is, as we spoke about earlier, the risk of trying to do too much in one initial rollout, turning this into, I mean, one of the things that will challenge organisations the world over is undertaking large-scale IT-based projects and having them blow out in time and cost. My own organisation, we're currently in the midst at the moment of a greenfield SAP stand-up. It's okay, it'll be delivered bang on time and without any single cost blowouts, I'm sure, like every other one globally. So what that means is the biggest risk is, and Alfredo was talking about this earlier as well, decide what scope you really need, decide what scope you really want, and stick to that and manage your risk by running to a very tight business case discipline. Get that over the line, prove your case, prove that the system actually works, and then you can build on it from there. And that's the steps on a journey towards the digital twin concept.
Earlier you had mentioned, Ty, about stakeholder engagement. Can you say a little bit about stakeholder engagement as it pertains to risk?
Absolutely.
And then we'll wrap.
I'd say, in my case, my experience within the business, you've got to win over your CFO. These are things that can cost a lot of money. Absolutely. In terms of within the business, my experience is there can be very often a high degree of ambivalence towards boldly going into this area. I certainly found that the engineers who now within our business are embracing this new technology with great enthusiasm were pretty casual and indifferent when it was first proposed to them. So you do have to, my experience is sometimes be a bit of a maverick and trailblaze out there with this. The key stakeholders, though, that I found is selling your CEO, board, and in particular hold of the purse strings on the vision. And then once they're over the line, the rest of it is relatively straightforward.
Great. We're going to do a quick lightning round, 1 minute. Everybody gets a closing comment. We'll start with Alfredo. We'll work our way backwards. Any closing comment you want to offer the audience, and then we'll go ahead and wrap up.
Yep. Well, I guess my closing comment would be that I actually want to add a little bit to what Ty said, in that yes, you want to divide and conquer, you want to limit your risk, but you also want to even divide and conquer whatever project you decide you want to work on. For example, even if you decide this project is what gives us high impact, it may be that it's too big, and maybe consider just creating a pilot for a small area, see what the return on investment is, and does it scale to the rest of your network.
Well said, well said. Sam?
Yeah,
The last words.
to further add to that, I mean, we talked a lot about risk. Now we're talking about risk mitigation, which is fairly straightforward. Do a little bit of homework. I would say if your ultimate goal is to deploy something very large and sophisticated, ask your software vendor to do a pilot project. It's amazing how much both parties will learn from that experience. They will not learn from hiring a consulting company to write up your system requirements and sending those to the vendor and say, this is our RFP, please respond. You will guaranteed not get a good result from that unless you work all that problem out later on. So there are ways to work collaboratively and to do business where both parties reach a mutual agreement on what's beneficial. And personally, I like to work with people in collaboration, not, God forbid, you're in a combative relationship between the customer and the vendor. That's almost always a recipe for disaster. So try to find people that you feel like will work with you and then share your goals and objectives. And I think then these types of things are quite achievable.
Great. Thank you all for your time. Can we give a hand to our panelists, please? We'll be around if you want to talk to us, so thank you all very much.